Welcome to today's mini lecture. This is part 2 following the lecture on neutralization reactions. So today we're going to talk about the actual titration. So what I need for you to do is to look in your notebook, and you're going to write these notes on your own paper, and then you're going to put them into your digital notebook. So what I'd first like to do is to show you what a titration curve looks like. So if I have a container with acid, it's going to have a very low pH. Okay, so as I start adding the base to it, that pH is not going to change a whole lot. It just very gently goes up. Then all of a sudden you'll get to a point where it goes like this and then levels off. So this is your acid, this is your base. And I'm choosing NaOH and HCl just because hydrochloric acid is a strong acid, NaOH is a strong base, easy to work with. So if I look at this, what's going to happen is right here in the middle. If I take from here to here and I look at the middle, that point is going to be what we call the equivalence point. Yes, I definitely want you to write this down, so make sure that you're following along with me. If you need to pause, get your paper out, then go ahead. You can catch back up. All right, so there's a couple of points that you need to know. This one right here, as it first starts, this is called the end point. Now, what's going to happen is when we do a titration, I'm going to have a container that has an acid in it, and that acid has an unknown molarity, but I do know exactly how much I have. Well, the way that I can determine where my endpoint is I can go back in and I can add an indicator. And what an indicator does in an acid and base reaction, an indicator is going to change colors when you get to a very specific pH. So the pH or the indicator that we like to use in all of chemistry is phenolphthalein. Phenolphthalein. And phenolphthalein is what you're going to see in your lab simulation whenever we go through it. But the reason that we like phenolphthalein so much is because the bottom line is it's clear. It looks like a water. I mean, it's just no color whatsoever. But when you get to the pH of right around 10, it trips. That means it changes color, and it changes to what we call a shock pink. So it's almost impossible for you not to see and tell whenever that takes place. So it goes to a shock pink. So let's make sure that we understand the parts of the graph. As we're down here, we're adding a little bit of base. It stays right here, and all of a sudden you start getting near that equivalence point, and the number of hydrogen atoms, the number of OH atoms, they start to become equivalent, and then all of a sudden you have a little excess of OHs, and now we get a pH way up here. So if I told you that this right here was the middle of the pH scale, that's 0, up here is 14, then that would be 7. If you have a strong acid and a strong base, then yes, you're not going to get any acid-base residues left over. You're going to get 100% water being produced. All right, with that being said, I want to show you how to work a couple of these problems. Titration problems, very, very simple. What you have to look for in the beginning is to make sure that everything in your balanced equation is a 1-to-1 ratio. So practice problem 1 says that I have, practice problem 1 says that I have 20 milliliters of 0.005 molar NaOH, and it is required to reach the equivalence point in a titration of 10 milliliters of HCl. What is the molarity of HCl? These problems, very easy to recognize. Number 1, it gives you an acid base, it gives you the quantities, and you're going to be missing one. Also, most of the time, they will either use the word titration or they'll use the word equivalence point or endpoint. So these are very, very specific just to our titration reactions. So we know that an acid plus a base always gives me a salt. So my my Na and my Cl make a compound, NaCl, and my hydrogen ion and my OH make water. I look at this and I'm going to balance it, teeter-totter, and it is balanced. So if everything is at a 1-to-1 ratio, it makes it real, real easy. I'm going to take the molarity, it's capital M, of my acid, the volume of my acid, and that's going to be equal to the molarity of my base and the volume of my base. So let's just read our problem and plug in the numbers. It says you have 20 milliliters of 0.005 molar NaOH. So NaOH is the base. So the molarity is 0.0050. I'm going to put that in parentheses. The volume is 20.0 milliliters. Then I come back over here and I keep reading. It says it's required to reach the equivalence point in a titration of 10 milliliters. So I know that the volume of my acid is going to be 10 milliliters. And it actually asked me to find the concentration or the molarity of the HCl, which is the acid. So guys, you see how easy this is? Yeah, it's literally this number times this number divided by this number. I solve for the one that I do not already know. So I'm going to go through nice and quickly and see what the molarity is of this. I end up getting 0.0050 times 20 divided by 10. And I'm going to get 0.01. 0.01 molar, and that would be my answer. So guys, it's literally that easy. These problems, once you recognize titration problems at a 1-to-1 to 1-to-1, no problem. So we come back up here. I want to work one more problem, and then there's a third problem and a couple of more that I've put into your notes that I want y'all to finish up. It says, in a titration, 27.4 milliliters of 0.0154 molar of lithium hydroxide is added to 20 milliliters of HCl. It says, what is the molarity of the acid? So very similar to the same problem we just worked at, practice problem 1. So I want to go back in. I want to say this time my salt is lithium chloride plus H2O. Balance it 1-to-1, 1-to-1, 2, and everything is balanced. So it is at a 1-to-1 to 1-to-1 ratio. So that means that since I am doing and working with a titration problem, I'm going to use MAVA equals MBVB. And guys, sometimes you will see this written as M1V1 is equal to M2V2. It doesn't matter if you use your whichever ones. You just make sure that you pair up your volume and your given concentration. So I'm just going to go through and see what we have here. It says I have 27.4 milliliters. So that's going to be over here, 27.4 milliliters of my base, and it's going to be at 0.0154. I'm going to set that equal to, is added to 20 milliliters of my acid, and I'm looking for my molarity of the acid. So I'm going to take out my calculator, 0.0154 times 27.4, and then I'm going to divide that by 20, and I end up getting a number for my molarity of my acid. I get 0.0154 0.0211 molar. All right, so guys, I hope that this has helped you. Along with your notes, you're going to have this with your notes, but I want you to finish the third practice problem as part of your notes. Then the worksheet that goes with it is on the next page in your notebook, and it has three problems that are set up, and instead of giving you the information like this, I put that information into a table. But you still solve it by number one, writing a balanced equation, number two, writing your formula, substituting in, and getting your answer. So I hope this has helped you, and I'm looking forward to seeing you in our next class.